You know what? I'm gonna actually pull out the I'm gonna actually do the stuff, do everything tonight. Uh, 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 um. So y'all know in the chat I put the consult link and the link to RSVP for the upcoming career accelerator session. Let me know if y'all can see my screen. Okay.
I can see it.
Okay. And was everybody able to connect to the VM?
Yes.
Let's go
Yes.
then. So I am going to record. If I can, oh, there it is. Okay. All right. So tonight we're going to take this as the opportunity to review everything and to introduce you to some new concepts. Tonight, the new concepts that you will have are your subqueries, your views, and your CTEs. I'll explain them in depth. And like I said, one of the benefits of that is that they aren't entirely new. They kind of extend or build upon things that we uncover or have discussed already in the past. But I did want to review some things tonight, especially things that are common. Well, all of these, everything that we've learned are pretty much common, especially coming into the space of data with SQL. But I wanted to take the opportunity to review things that we had already covered in previous sessions, just to kind of reinforce or reiterate some of the expectations. The session before last, we talked about aggregate functions, and aggregate functions are when we get into the data analysis part of SQL. How many did this? What's the average of this? What's the sum of this? What's the min of this? What's the max of that? Those are those aggregate functions. And the appropriate way to format your syntax to capture those aggregate functions, you had your select statement, like how we always do when we are retrieving data, we are selecting. Here we have our aggregate function, which in this syntax or example here, we have sum. Then we have purchase amount. This is whatever we are performing a calculation on, we are going to put it in those parentheses. And we're always pulling data from a table. Whenever you're retrieving data, you're retrieving data from a data source. And in this case, it's a table. We are selecting this function from this column from this table. Same with our average. We are performing an average on this column. Count. We are counting. In this case, it's the count stars. So we're essentially saying count all the records from this table. Max and min, same thing. The part that trips people up on these ag functions is they group by and they have it. Remember when we group by our ag function, we are grouping rows that have the same values. It's just like in the way that my brain conceptualizes the group by. Here is like a conveyor belt in the grocery store. You got a conveyor belt, and on that conveyor belt, I want to separate my produce. I want to separate my dairy. I want to separate my milk. So from that, I'm saying I want the average. Hey, Shakita, I want the average of milk of dairy. So I still want to calculate. However, within the calculation, I want the ability to group those like-minded things together. So give me the average amount by product. Give me the average amount by customer. Give me the average amount by city. Give me the average amount by state. I want the ability to calculate, but group it too, though. Calculate, but group. And the syntax for that is select our columns, customer. The aggregate function here on this column. Add this value from this table and group it by customer. So calculate, count the order IDs by people too. And the way that my brain understands having ain't nothing but a filter. That's it. That's all. The same way we say where order ID is one, where customer equals John, where amount equals 100. Having performs the same way. However, with having filters by that aggregate function. So whereas we say where order ID equals one, in having, we're going to say having sum of amount greater than 300. So I'm going to filter that data, but I'm going to only filter that data by a calculation. That's how having functions. Unlike where, having only filters rows after you calculate those rows. And this is a good visualization for you to kind of see side by side the difference between where and having. Both of them are filters. They both are going to filter that data. However, they perform differently. Having is going to filter it by the aggregate function or by the calculation, and where is going to filter it by the individual column level, column row filter. Any questions on that? The next big thing that we discussed last week, and we're also going to perform some joins today as well, is joins. And I hone in on this because it is so they're so pertinent. And like what you do is almost like whenever you start to interview, have an expectation that if you don't do a live technical session, that someone along the way is going to ask you about these different types of joins. And the reason being is because in reality, your data is going to live in multiple tables. So for you, you have the ability to understand how to relationships and to join those multiple tables together to answer whatever question you're trying to answer. So the four common types of joins, we have our inner join, our left join, our right join, and our full outer. Our inner and our left gonna be our bread and butter. That's gonna be the gist of how you perform. However, at least know I have a even if you have like a image of like your joint, at least have something where you can be able to explain how they operate. But the inner join only brings back common data between both of those tables. I got my data from this table, I got my data from that table. Where they overlap, give me that data. And remember that inner join has the ability to possibly eliminate very valuable data. Why? Because it has to exist in both of those tables. If that data doesn't exist in both of them tables, it's not going to come back. It's like it doesn't even exist at all. Left join. All your data from your left table matching data from your right table. All your data from your left table matching data from the right table. If that data doesn't exist in that right table, it's gonna bring back like the column, but it's just gonna say no because it doesn't have any data to populate in that field. Right join, basically the opposite of left join. All data from the right table, matching data from the left. You're not gonna use it, but just know it. You're not gonna use it, but just know it. Full outer join. All data from all tables, whether it's a match or not. Give me all my data from this table, all my data from this table. I don't care about matches. I want all the data. Any questions on this? This is your syntax for your inner join. The beauty of joins is your syntax is the exact same every single time. The only difference is you specify which join. So your syntax for your left join is gonna be the same as this. Same, except you just specify like left join. And that syntax is you select e.name. So I'm essentially pulling the name column from this table. D.department name column from my department table. These here are called aliases. This is my employees table. I'm gonna name it E. So whenever in my syntax I reference E, I'm referencing or I'm talking about this table here. Same way with this department table D. Whenever I am referencing D as a table, I'm talking about this department table. An alias is no different than how when you go to the DMV, first name, last name, alias. You still are very much so your first and last name, but your alias is essentially a name that you go by as well. So if I call you by your alias, I'm still very much so talking about you. This syntax down here, when we say select column from this table, join this table on what though? On E data relationship. Data relationship, I cannot all the way from SQL to Excel to Power BI to Python to Tableau. Anything you doing in data, I don't know, I don't really use Salesforce, but if it uses data, anything that pretty much uses data, that understanding of data relationships is going to be key for you because it's going to help you be able to join those two data sets together and keep your data in shape, keep your data integrity together. Any questions about this inner join? Left join, same syntax, except we're going to specify left join. Left join will the data from your left table, matching data from your right. When I say left table, I'm talking about the data to the left of my join statement. So this is my join statement. This is my left table. Left join and right, like they used to be really weird to me because like, what do you mean left and right? But it's essentially talking about the table to the left of your join statement. And down here, you joining them tables on what though? On the data relationship. Where is the common field for both of those tables? How are these tables relational? Your left join is going to return data, all your data from your left table, matching data from your right table. That's it. That's all. If that data does not exist in your right table, it's going to still bring the data from the left table, but it's going to say no. It's just not going to populate that field. Any questions on this one? I need literally all the data. Like I need the data. That data from this table has dependency on my data from my second table. I don't need just half of that, my data. I need it all. So the inner join is going to give you the ability to only bring back matching data from both of those tables. And it's also a really good way for you to check to see if data exists in both of those tables. Like if you're doing data investigation and then left join, let's say you are writing your code and you need, for example, like this, I need all the employee data, whether they have a department assigned or not. So that left join is going to pull back all of this and only data that matches from my other table. So yeah, the inner and left gonna be your like bread and butter. I ain't no people don't use right joins, but they ask it on interviews. Because these are like your four major, but in the real world, it's gonna be left and enter. And the
Okay.
beauty,
I'm
huh?
trying to write down what you said. Okay, so the left join, it's only going to match all the data. It's only going to return all the data that matches. But you said the inner join.
Wait. All the data from the left table, period.
Yes, that matches.
All the data from the left table and only matching data from the right table. All from left, all from left, and matching from the right.
And inner is going to give everything, and if it doesn't match, it's going to say no.
Nope. Inner is only going to bring back common data.
Okay.
So I got this table, and then I got this table. I'm only getting the matches in my inner. Think about it like a Venn diagram, like this. This all I'm gonna get. All data from the left, only matching from the right. So regardless of if it's a match or not, it's gonna give me my data from my left. But if it's not in my right table, it's only gonna pull in, like it's not gonna pull all my data from the right table. It's only gonna pull in data that exists in that left table too. So it gotta exist in both of them. And if you're like a visual learner, these images right here, I had these images saved as a bookmark, um, and the syntax saved as a bookmark probably until like 2019. Honestly, like, and I had been in data for like 6 years still at that point. And every time I would do a joint, I would literally like look at this.
Okay. I can do that.
Mm-hmm. Because even when I would be on interviews and stuff, I would have like this something like this or like this, like right in my face. I'm just now, I would say, probably like 6 years in, to where I could like regurgitate it real quick. But before that, I would have some up in front of me. But if you visual, like this image here is exactly how it behaves. And when you are in interviews, I can't count how many times somebody is like, so what's the difference between the joints? And then the way you explain it, just how you was gonna explain it, that answer will suffice. Like the right way, left and inner and right and full. And that's the answer. Yep. Any other questions? And these aliases, people's brain works differently. You can make your alias whatever you want your alias to be. If your table name is employees and you want E, make it E. If you are one of them people that need like A, B, C for every table, put your A, B, C on there. If you're a person that would prefer like numbers, put your numbers on there. Like whatever feels comfortable for you. So you know that if I put E, I'm talking about this table. You well within your rights to do that. Or if you don't even want to include an alias, you don't even have to include an alias. Any questions on joins? All right. Let's go into our database before we get into tonight's objectives. And let me know when y'all are connected. You can put your thumbs up or something.